Hello, I'm Sindhu. Today we are together with a computer organization. What do you mean by computer organization? So here computer is nothing but it contains input device, output device, monitor, CPU, mouse, etc. Right? Here how these all parts of the computer is together working. So in this computer organization, so it is divided into 5 functional units, right? So that is, first one is input unit, and the next functional unit is output unit, right? So this is 2 units, functional units, and another one is memory. Another one is memory, right? So after this, it is very important, another 2 functional unit is, one is control unit, that is CU, and another one is ALU. So combinedly we call it as processor, right? So here first is a input unit. So what do you mean by input unit? So here the user can give information or any input to the computer. By using this input unit, user can give input to computer. So for example for this is, it can be keyboard or mouse, or it can be anything, right, etc. And another one unit is output unit, right? Output unit, by using this output unit, the user can view the output. So example for output unit is monitor and printer, right? So if the user need to store the data for further use, so in that case they'll use memory. So memory here it is a storage device, right? And if the user need to perform any arithmetic or logic operations, so say for example your C program, addition of two numbers, so in that case your computer will use the arithmetic and logic unit, arithmetic and logic unit, right? So next, to control all these operations, input operation, output operation, storing, and arithmetic and logic unit operation. So to control all these operations by this control unit. So in this computer organization subject, in the first module we are studying only the basic things, and in the further modules, in the second module we are studying about the input and output devices and input output operations, and in the next module we will study about the memory operations and circuit and different operations on the memory. And in the next module, in the next 2 modules, we will discuss about the ALU operations and the control unit operations. Okay. So in this, yes, so in the first module we will discuss about the basic operational concept, that is your first topic. So in the basic operational concept, yes, take an example of C program, addition of 2 number programs. So in this is your main function, and next, so declaration part, int a is equal to 5, b is equal to 2, and c is equal to a plus b. Then we will use printf statement. So here %d and C, right? This is your C program, right? So can your computer will understand the C program? So is it the same way how you are writing the C program? Is in the same way your computer will operate these instructions? No, right? So to execute this program in your computer, it contains the set of instructions. So that set of instruction, it is called it as machine instructions. Machine instructions. To execute this program, we need machine instructions. Okay. So next, so what is this machine instruction? So here, yes, we know that always your processor will take the data from the main memory, not from the secondary memory. Always please remember this, always your processor will take the data from the main memory. So here I am explaining some simple set of instruction here. So first one is load instruction. So what do you mean by load instruction? Here your processor will take the data from the memory. So here the load instruction, it is used to take the data from the main memory and it will be stored in the register. So load is an instruction, it is used to take the data from the main memory and store it will be in the register. And the next one is store instruction. Store instruction. So here store instruction, it is a opposite process. It is after adding two numbers, again the result will be stored in the memory, right? So here store is an instruction, it is used to store the data from the register to main memory. Okay. So next is for arithmetic and logic operation, we have different types of instructions. So first one is add instructions. Add. So add is an instruction, it is used to add the two numbers. And likewise for arithmetic or operation, sub is also a instruction for subtraction, and mul is also a instruction for multiplication, and div, it is used for division. And likewise, so for logic operation, or, and, these are all the instructions. Okay. So take an example of this. So this will be converted into instructions, right? How? So here first in your memory, so this is your main memory, this is A and this is B. So A will contain value 5 and B will contain value 2, right? So here for adding this number, this will be converted into instructions, right? First your processor, this is your first step, your processor first it will take the data from the main memory to register, right? How? For that here we are using load instruction, load. Say for example this is location A, comma R0. Here R0 is the register. So register is also a memory, it is a very small memory, it is present inside your processor. Okay. Next we want to take the value B, right? So how? Again here also we are using the instruction load, and which is a location name, here it is a location B, and that will be stored in the register R1. So next, what is the next step? Addition of two numbers. Now the value 5 and 2, it is in the register. Now that 5 and 2 will be sent to the processor ALU part, and that will be add, and again the result will be stored in the main memory, right? That is the process. Next is the add instruction, add R0, comma R1. Here please remember, here the location A data will be stored in the R0, and same way location B value will be stored in the R1. Here we are adding R0 and R1, but the result will be stored in the R1. So the previous content of R0, it is remaining same, right? But the R1 value, it is replaced with the new value, that is the result. Okay. So 5 plus 2, it is 7. So initially R0 contained 5, R1 contained 2. Now after this execution of this instruction, the R1 contained the value 7. Now this is R1 contained the value 7. This is the result. Okay. So next is, again you need to print, or you need to show this result to the user, right? So for that you need to copy this again into the main memory. How? So for that, here store is an instruction. It is used to store the data from register to main memory. So for that, here I am using the instruction store. Here R1 comma where in the location C, right, location C. So this is called instruction. So this is called instruction, machine instruction set. Instruction set. Okay. So how this will be work, how your main memory and processor will communicate with each other. So for that we are discussing a simple diagram here. So say for example, this is your main memory and this is your processor, right? So inside this processor we have different types of registers, right? So first one is memory address register, memory address register, and another one is called memory data register. Okay, next is here, next is PC, program counter, and another one is IR, this is instruction register, and we have some set of general purpose register. Here R0, R1, so for any arithmetic and logic operations we are using this general purpose register, right? So apart from this we have CU and we have ALU, right? So this is the structure of your processor. Now what is MAR, memory address register? So it contains the address of the actual data, where this instruction or actual data is present in your main memory. That address will be stored in the MAR and MDR. So what does this MAR contain? Address, right? That related data will be stored in the MDR, right? This is the general purpose register. Next is PC. PC is a program counter. This program counter, it will contain the address of the next instruction to be executed, right? And next is a IR. IR means instruction register. Instruction register, it will contain the instructions, right? And the CU is control unit. It control all operations of your computer, and ALU, it is used for arithmetic and logic operations, right? Okay. So take the same example here. Take the same example here. This is your instruction, right? So say for example, initially the first instruction address can be 1002, right? So next instruction address can be 1004 and 1008 and 1012, right? So you need to execute this program, this instruction. Initially the program counter, so you need to execute this instruction. The initial address of the instruction will be first stored in the program counter, right? So initially now program counter contain 1002, right? So once it start executing, this will be replaced to the next instruction, which is the next instruction. So 1004, right? So replace this with the 4, right? Now this 1002, right? 1002, that address will be stored here. So here 1002. Right? Now, so it will search 1002, it is in here in the main memory. Now first load will be sent to the MDR. Now it contain load instruction, right? Now your CU will check this. Yes, this is the instruction, right? So that instruction will be stored in the which register? It is stored in the IR register. So now this load will send to the IR register. This is load now. Okay. So what is the next word? It is location A, right? Location A. Location A is a value. What is that value? It is 5. Now again it will be sent to here, data 5. Now again CU will check. So this 5 needs register or ALU? Yes. So for this confusion again. So now your CU will check the next word. Which is the next word? It is R0, right? So now R0 is a register. Now your CU will understand that yes, this 5 will need to store load, right? Load is an instruction. So load, so 5, now this 5 will be stored in the R0 here, 5, right? CU will check the instruction and this will be stored to R0, right? So that whole line will be executed now. So next it will check the program counter value. Now program counter value was 1004. Now this will be MAR value will be replaced with the 4 now. Now this is, it contains the next instruction address, right? That is 1008. Now here it is empty, right? Now again, so it will take the first word, that is load. It will come here MDR. Now your CU will check, yes, it is a instruction and send that load instruction and it is stored in the IR register. Now it will check the next word, that is location B. Now location B, it will contain value 2. Now your CU will check this, yes, it is a value. Now it will check the IR. So yes, load is an instruction, it is stored from memory to register, right? Now store 2 in the here, right? So now that line is executed now. Now it will check the program counter. Again, yes, it contains address, right? 1008, and it will be replaced here 1008. This is empty now. Okay, now it will be updated to 1012 now, right? Okay, now again 1008. Now here add is the instruction. So MDR contain add, and again yes, your CU will check here. Yes, it is the instruction and this instruction will be sent to IR. Now IR contain add instruction. Now so next two is a register. It is present inside the processor, right? Now your CU will check. So this instruction need ALU or not? Yes, it needs ALU. In that case, this 5 and 2 will be sent to here, and it will add and 5 plus 2 and the result is 7. So where you need to store this result 7? Yes, exactly, it is in the R1, right? So R1, right here. So again this 2 will be replaced with the value 7, right? So that means this line is also executed now. Now yes, your CU will check PC. Yes, it contains next instruction address, right? Now it will be replaced with the 1012 now. Now store. Now PC is empty because there is no next instruction here. So now this PC will empty now 1012 now. Here it will check the that line, and that is store. Again store here, your CU will check and it needs IR register, and this will be replaced with store instruction, right? Now store instruction here, from where to where? From R1 to location C, right? So from R1 to location C. Now this will be sent to MDR 7, and here it will contain the address of the memory location, and this will be stored, the result in the memory. 7 will be stored in this location. This is all about the basic operations of your computer, right? So this completes the first topic, basic operational concept. Here we have some set of instructions. So how your memory will communicate with the processor. So inside this processor we have some set of registers. So in that main is MAR, MDR, PC and IR, and we have some set of general purpose register. Number of general purpose register, it depends on the computer, right? Next is ALU, it is used for arithmetic and logic operations. To control all these operations we need CU, control unit, right? So next is bus structure. What do you mean by bus? Bus in general, it connects two locations, right? So it you need to travel from one place to another place. Yes, you need bus or any vehicles, right? Here also, so see here we have arrows, right? We have some lines, arrows, right? So this shows how your memory and processor will communicate with each other, right? So here we are showing this lines. So inside this lines we have some set of wires. So that set of lines or set of wires, it is called it as bus. So what do you mean by bus? It is a set of wires or set of lines, right? So why we need this bus? So this all data will be transferred from one place to another place. We need bus. So that bus is a set of lines or wires, right? So from each line it will carry only one bit. From each line it will carry only one bit, right? So here in this example we are using single bus structure. Single bus structure. Okay, so what is the single bus structure? Yes, so before we take up the single bus structure, here we have some lines, right, from MAR, MDR and CU and all, right. So inside this also we are connecting like this, right. Okay, these are also buses. So here we divide this bus into three types. One is address bus. Mainly we divide this bus into three types. One is address bus and another one is data bus and another one very important is control bus. Here MAR and memory will communicate through this address bus. Address bus, and MDR and your memory will communicate with each other. How? By using which bus? It is data bus. And the last one is control bus, right. So this control bus, this control information will be sent through by using which bus? That is control bus. Okay. So this address bus, it will carry only address information, right. So in the same way data bus, it will carry only the data, and the control information it will be transferred by using this control bus, right. So here in this we are using single bus structure. Single bus means we are using only one set of wires. So here in the single bus structure only two devices can active at the same time, right. Say for example this is the bus, right. So this is your input unit, this is your output unit, and this is your memory. See for example this is your processor, right. So here so this is the bus, right. So here in a single bus structure only 2 devices can active at a time. For example, you need to enter A and B value. So in that case only input device and the memory will active, right. So in the same way you need to print 5 pages of PDF file. So in that case only memory and the output unit will be active. So here in the single bus structure, yes, it is a very low cost, and that is the advantage. It is a very low cost, and you can it is very flexible. You can add the peripherals very easily. It is very flexible. Yes, but you can use the multiple bus structure, but we are not using multiple bus structure. Here say in the multiple bus structure many devices can active at any time, and here for parallel processing your computer performance may be high, but we are not using multiple bus structure because it is very high cost, right. So in this we are using only single bus structure. Why? Because it is very low cost and very flexible. Yes, we can use multiple bus structure, and here your process can be done parallelly, but we are not using because of high cost, right. So this is all about your bus structure. So take an example, another one example, for example printer, right. So compared to input and output device, memory speed is high. So compared to your memory, your processor speed is high. So here we are using different buses, right. How these operation will be synchronized? So for that we need buffer. Say for example your memory contain, say for example 5-page PDF. 5-page PDF. So you need to print this PDF file. How? So your output device may be your printer. So speed of the memory and the output device is different. So for synchronization purpose we use buffer inside this printer, right. So to synchronize the speed of the memory and the output device, we need buffer, right. This is all about your bus structure, right. So in the further classes we will discuss about the performance of your computer and what is clock rate, what is spec rating and all. Thank you.